All right, let's move on to another feature. And even though there's two things written down, it's really kind of important to note that this is a singular feature found in a quadratic function, and that is each quadratic function will have a maximum or a minimum value. And I know I wrote finding maximum and minimum values, but basically it's going to have one or the other, because that maximum or minimum value is when you think of any kind of, I'm just going to draw a rough parabola here, is going to always be that point where it turns and it goes in the other direction. And we know what that's called now. We have a name for that, and that name is, and this is tightly linked with the vertex. All right? And so basically, if we can figure out what the vertex is, we can figure out whether our function has a maximum or minimum value. So the very first thing to think about is we are going to be doing these without the help of a graph. All right, so so there's a few clues we want to look for. So the very first clue we look for, and I'm going to highlight this in yellow, all right, is we always want to go and we want to look at this first term. We want to look at your a term, because your a term, your ax squared term, that a is going to tell me one really important piece of information. And it's going to tell me which way the graph opens. Because if a is, greater than 0, then it opens upward. If a is less than 0, it opens downward. And we'll talk about transformations of these in the next lesson, but basically I'm looking at this and I already know that this graph is opening up downward. Now, because the graph is opening up downward, that means that it's going to basically look something like this, right? And that point, the vertex, is on this particular graph is going to be the highest point on the graph. So if it's opening downward, it's going to have a maximum, and if it's opening upward, it's going to have a minimum. All right, so does the function have a minimum or maximum value? This question right here, it has a maximum value. All right, so we would mark that right there in blue. Okay. It says, where does the minimum or maximum value occur? Well, think about that. Where is the vertex? The vertex is always lined up with the axis of symmetry, right? So if I can figure out what the axis of symmetry is, and then put in my value for x, figure out what it is, I'm going to be in good shape. All right, so let's do that. Let's figure out what the axis of symmetry is. So the axis of symmetry is, let's do this in another color, is, I know that is negative b. Oh, that's a bad color. That doesn't show up at all, does it? Let's do red. Here we go. Is negative b over 2a. There, that shows up well. So look at the equation. My b term is going to be right there. So it's negative b, so it's negative 20 over 2 times a, and a is negative 2. All right, so negative 20 is just 20. 2 times negative 2 is negative 4. So my axis of symmetry is going to be the equation x equals negative 5. All right, so that's not where my minimum or maximum is. All right, it says, all right, well, actually, it does say, where does the minimum or maximum value occur? So they're looking for your axis of symmetry for this question right here. So that would be x equals negative 5. So this one is all done. And then it says, what is the function's minimum or maximum value? So your minimum or maximum value of the function is going to be its highest or its low point. Well, a high or a low point on a graph is going to be measured by your y-coordinate. So it's going to be the y-coordinate where x is negative 5. So all you got to do is we're going to take this, and I'm going to do the work down here, and then we'll get rid of it for this last bit here. Is we're going to take this, and we're going to go negative 2 times negative 5 squared minus 20 times negative 5 minus 48. And then it's just a matter of just figuring this out. Well, negative 5 squared is 25 times negative 2 is negative 50. and then you get positive 100, and then minus 48. So you've got negative 50 and negative 48, which is negative 98 and positive 200. So your point is 2. So the function's maximum value is at 2, is what you would write. And if they were asking for a point, it would be the point negative 5, 2, because it's on that axis of symmetry. All right, and then for this last part here, okay, if you have to go back and look at my work, you can, stop and rewind the video. I got to get rid of this right now. So for the last thing, let's take a look at the domain and the range of the function. Well, I know the domain is going to be all real numbers because that's how these work, right? You can plug anything in for x and you'll get some kind of a value. My range is going to be all the y values, so we're going to go y such that y is, and if you have a maximum, it means every other y point is going to be below that. So y is less than 2. 2 is my maximum value right here. That means all my y values will be less than that. All right, so I hope this is helping you out a little bit here. I'm going to do one more example similar to what they have in the book. So it says we have the function blah blah blah. Determine whether g of x has a maximum or minimum value, what it is, and then state the domain and range of g of x. All right. Well, I look at this right away and I look at 2. 2 is positive. So that means that this opens upward. All right. So it's going to be something that looks like that. So g of x, to answer the first part, has a minimum value, and then we'll say of, and we'll leave that blank because we're going to figure that out. Let's find our axis of symmetry. All right, so find our AOS. All right, so that is going to be negative b, so negative 4 over 2a, 2 times 2. Well, negative makes positive 4 over 4. So my axis of symmetry is the line x equals 1. And then I'm just going to take that 1 value and I'm going to put it in there to see what my minimum value is going to be. So I'm going to go g of x. So we're going to figure out what g of 1 is. So we're going to go 2 times 1 squared minus 4 times 1 minus 1. So you get 2 minus 4 minus 1. So you get negative 3. So g of x has a minimum value of negative 3. All right, and the point would be the point 1, negative 3. All right, it's that simple. And then when you look at what's your domain and your range, your domain will be all real numbers, and your range is going to be your y values, right? Sorry, you're looking at my Twitter feed here. Your y values such that, I don't know what happened there. See, I'm getting thrown off. Range is your y values such that, that's what that line means, that y is going to be anything that is greater than or equal to your minimum. And your minimum is negative 3. So it's anything that's greater than negative 3. All right, so you kind of get an idea about what's going on here. Finding that you're using that negative b over 2a equation that we learned in the previous video to find your axis of symmetry. And then once you do that, you find your vertex. Your vertex is going to be your minimum or your maximum. And if you can remember that, you're in good shape. Domain and range kind of follow suit after that.